Ladies and gentlemen, thank you for your patience in holding. We now have your speakers in conference. Participation in this conference call is by express written invitation of the AHA only. Unauthorized participants and or any party that aids and abets such unauthorized participants may be subject to criminal and civil penalties under both state and federal law. Please disconnect from the call or log off the webinar if the AHA did not expressly invite your participation. During today's presentation, a video will be played. If you are dialed in over the phone, you will need to unmute your computer speakers in order to hear the video. Please note that due to limitations of the web platform, some animations and or pictures may not be available. Please be aware each of your lines is in a listen-only mode. At the conclusion of today's presentation, we will open the floor for questions, and at that time, instructions will be given as to the procedure to follow if you would like to ask a question. It is now my pleasure to turn today's conference over to Scott Steinler. Sir, you may begin.
Thank you. Good morning, everybody, and well, good afternoon, depending on where you are, and thank you very, very much for joining me today. My name is Scott Steinler. I'm the Western Regional Manager with Blucher Pipe and Drain. We are a division of Watts Water Technologies. Before we get started, I just kind of wanted to let everybody know that if you have any questions, audio is unrecognizable we're getting. Can somebody confirm that the audio is good or bad at this point? Other?
We can hear you, sir.
Okay, so yes, we are good on audio. If you do have any difficulties, I apologize. But I did want to let you know that if there are ever any questions at any time during the presentation today, please do not hesitate to ask them. You can ask them in the chat window, or you can raise your hand and we'll go to audio. My intention is really to have more of a conversation with you, if at all possible, rather than a presentation. PowerPoints, you know, they do have a tendency to get a little dry. So if I don't get through the slides, if we segue or go in a different direction, I'm perfectly okay with that. If I don't have an answer for you today, I will do my best to get an answer for you at any point and get back to you as soon as I possibly can. So with that, let's just go ahead and push forward. So today what we're going to talk about in particular is Blucher in the healthcare environment. So this is really pertinent to all stainless steel, but for my purposes, I'm talking about Blucher. I was not informed that this presentation needed to be non-proprietary in any fashion, so there is some manufacturer-specific information in here. If you decide you would like to go ahead and have this presentation done at your office, or if you would like to maybe bring some of your facilities people in to a conversation and you are looking for CEUs or PDHs, I can go ahead and do whatever I need to do to remove the branding from the slides, and we would be more than happy to have a conversation with you. So let's get into it. So these are just a couple of case studies. We have Blucher at Children's Hospital, Hong Kong. Just a nice little case study there for you. So what I wanted to talk to you about is application highlights for stainless steel in the healthcare environment. So stainless steel itself helps to mitigate bacterial and virus propagation in the drainage systems and really reduces your risk of hospital-associated infection. It is a preferred piping material for kitchens due to grease waste transport. Laboratory waste is suitable for this. Sanitary waste, vacuum systems. This is really to be considered where you're looking for a long return on investment and you're looking for that corrosion resistance. Additionally, stainless steel can be used in plenum and other areas where you're looking for non-combustible materials. We have dual containment piping configurations available. As far as the acoustical properties of stainless steel, it's right up there. It's not quite as good as uninsulated cast iron, but if you do insulate the stainless steel, you do get some very good acoustical properties out of it. We are a push-fit joining system, acid pickled. Fully customizable solutions to meet really any of those kind of odd applications you may have. And we're very, very cost competitive when compared to conventional drainage system installation. So it does provide superior protection and that ROI that we mentioned earlier. And it's really for anybody that's interested in maintaining a safe and functioning facility with a minimal amount of downtime. So here's a picture I got from my friends over at South Coast Engineering Group. They're located here in Southern California. I have a coworker, her name is Jenna, and she had a interesting slide on looking at a building as more of a living, breathing structure than anything else. I thought that was kind of a fascinating way of looking at it. So just like a human body, I mean, you're processing fluids, you're getting rid of those fluids, gases. So when you look at the building in that in that sense of it actually being a living and breathing entity, that really helps you to kind of understand what's going on with the infrastructure and why there is a problem with these HAIs and why we do have some interesting problems that occur within the buildings. So what I'm doing now is actually viewing my slide notes. I kind of have to do it off to the side. We're having some interesting technical issues with this. I'm not too familiar with the Adobe software. It's definitely interesting. Okay, so let's go back to this slide, and I'm going to ask our operator to go ahead and play a slide for you right now. Play a video.
Okay, everyone, we're going to play a video now. Please unmute your speakers if you're on the phone.
On any given day, about 1 in 25 hospital patients have an infection caused by their medical care. Almost half of these patients are 65 or older. There are 5 places where patients are most likely to get infections: in the bloodstream, the urinary tract, the gut, and the 2 most common places are the site of surgery and the lungs. The germs most likely to cause healthcare-associated infections include C. difficile, or deadly diarrhea, staph, including the drug-resistant type known as MRSA, a family of germs known as Enterobacteriaceae that includes CRE, the nightmare bacteria, Enterococcus, which can be resistant to an important antibiotic, vancomycin, and Pseudomonas, which can cause infections of the lungs and bloodstream. 1 in every 9 patients who gets an infection will die during their hospitalization. Over the last several years, great progress has been made in preventing some infections. For example, bloodstream infections in patients with central lines have been nearly cut in half in the last 5 years. But more work needs to be done. CDC's goal is to eliminate all healthcare-associated infections. We work 24/7 to save lives and protect people.
So we're now going to wait approximately 15 seconds just to make sure that anybody buffering has a chance to catch up. Brandon, you want to let me know when we're ready to push forward?
You're ready to go, sir.
Okay, so we are ready to go. So let's go into the next slide. So that I found that one when I located that movie on the CDC website. I found that to be absolutely astonishing. Just the percentages of cases of healthcare-associated infections are so extremely high. And then I started looking at the costs associated with that. And again, I'm going to default to Jana. Now, Jana, she's one of the WASP people, and she spent a lot of time on the Legionella end. So I asked her if we could possibly locate, how much money is associated with these HAIs. So, there's a bunch of articles out there on the internet, but most of them are referencing an article that was written way back, I think, in 2005. So what we did is we were able to locate an article that was from 2015, and it estimated that the costs at that point were about 96 to 147 billion at that point. I then took let's say a 1.09 inflation rate, multiply that out, so that's $160 billion. So to give you just some idea of how vast that number is, and what's interesting is, you try to wrap your mind around what a billion is. It's one of those numbers that you just can't do. So what I did is I took the length of a dollar bill, put it end to end, and figured out how long that was going to be. So if we were to line up that amount of money, it would wrap around the equator of the Earth 623 times. So it's just an incredibly vast amount of money. Then I took that, let's say we have 192 nations on the Earth at any given time, plus or minus some African countries here and there. We have higher healthcare associated infection costs than there's only 56 nations in the world that have a higher GDP than we're paying out in healthcare associated infections. So it's absolutely a vast number. Too much. So what can we do, and where is it coming from? So obviously everybody knows what the COVID, the SARS-CoV-2 looks like, of that virus. I said I wasn't going to, I promised Mark at the onset of this I was going to take the high road. I wasn't really going to focus on that. But unfortunately, it is very topical, and it is something that's worthy of discussion. So we can just kind of, let's get rid of the COVID-19 and just refer to all these viruses as SARS, all right? So we have these SARS virus. How are they being transmitted, particularly in the healthcare and in these like multiple family units? So what I did is I looked back at SARS-CoV-1, or the one that hit China several years ago, and what they discovered is that was being transmitted through dry traps. So everybody knows what a P-trap looks like. Showed you one in the bottom right in case you don't know it. But what they figured out is that these traps, they were either siphoning or they were just drying out. And we were getting virus transmission in that fashion. So this, okay, it was back in 2003 is what I'm looking at. So according to the World Health Organization, it was ineffective P-trap seals in the drain pipes of the garden apartments is what triggered the first SARS outbreak in China. So again, we're seeing kind of that this is repeating itself. And I'm going to go ahead and go to the next slide, and this is pretty interesting. So ASU and the University of Arizona, what they are doing, and I have a link to this article if anybody would like to see this after, they're looking for traces of COVID-19 in the wastewater stream. And what they're doing is trying to use that as an early warning of the virus's spread throughout their communities. So it's very similar to what people were doing way back, I believe it was the northeast portion of the country when they were trying to ascertain how bad the prescription drug problem was up there. So what they were doing was analyzing the waste stream and measuring the amounts of trace drugs that were in the sanitary systems. So why am I talking about this? I guess the long and short of it is that anything that we put inside the human body or anything that we're excreting from the human body ends up in the waste stream. And that's the problem here, and that's what I wanted to really get into with you. So according to the CDC, they're indicating that evidence indicates that sinks and drains, toilets in healthcare facilities, they can become contaminated with these multi-drug resistant organisms. Then it sticks to the pipe. Okay, we got some errors here that I'm seeing. Nothing is being shared. Only see a blank screen. Well, I'm going to defer to Brandon on that. Hopefully we can get that figured out for you, Jason. Again, I apologize. And I'm going to just keep pushing through for you. So the problem is the biofilm formation in pipes, and let's talk a little bit about that. So what pathogens are we finding in the drainage system? Well, here's a list that I pulled out for you of just a few of the bacteria and pathogens that are and viruses that are being found within the plumbing systems. So we've got various fungi. We've got obviously SARS, SARS-CoV-19, foot and mouth disease virus. Pneumonia obviously is a big problem for everybody, several different types of pneumonia. And this is all coming from the drainage systems. Okay, Brandon is reminding everybody that if you do have a technical issue, please send a message directly to the operator. In this case, it's going to be Brandon, or you can send it to me. Brandon, would that be correct? Just have him send it directly to you?
Just send it to the host or me, correct.
Okay, yeah, you would just send that message to myself or Brandon to straighten out any technical issues. So let's talk a little bit about biofilms. So biofilms are obviously present in all the plumbing systems. We have them on the supply side, and the focus really here is going to be on the waste side. Now, what I didn't tell you during the introduction is I spent about 20 years as a plumbing and fire protection designer, worked on multiple hospitals. My last real job as an engineer, I was working down in the New Orleans area on ASHE hospitals with a company called YKM Consulting, and did quite a bit of expensive hospital work. Well, nobody had ever really come in and talked to me about the biofilm formation in the waste system and what a serious problem it is. So biofilms by themselves, again, are not necessarily an issue. You get these bacterial cells that are present, they're naturally occurring. They adhere themselves to a pipe wall or to any surface for that matter, and then they excrete a slime layer. And what happens is that slime layer can get up to millions of layers thick, and it becomes resistant to antibiotics. Now, again, the biofilms may not be a problem themselves, but the real issue here is that it provides a hospitable environment for possibly aggressive pathogens to live, breathe, and propagate. Food, water, and shelter is what these things really need to do their deal, and that's what the biofilms provide for them. And we know that the biofilms have been connected to about 80% of all bacterial infections within the U.S. you don't believe it, go home to your shower and you kind of run your finger down the corner. You will feel biofilms there. Let's go ahead and advance here. Okay. So when I first started with the company, coming from an engineering background, I thought, okay, how interesting is this going to be? I'm going to talk to people all day about holes in the ground with metallic walls around it. Sounds like watching paint dry. I wasn't interested in it. Fortunately for me, I'm also a terrible, terrible insomniac, and I really do have an interest in knowing what I'm doing and why. So I started looking at the material properties. Why stainless? Why are we looking at it in this application, food service? What makes it an acceptable material? I thought the rough surface on the inside of the pipe would be the real cause of the bacteria or propagation of pathogens, but I was wrong. And I love when that happens, when things go against kind of my preconceived notions. And that's exactly what happened in this case. I started looking at PVC piping thinking, hey, this is going to be great for any type of application like this. And what I discovered was that the porosity of the material itself allows for these little microscopic pathogens to get in there, and they're protected with the formation of the biofilm. So what I did here is kind of took a look at all the different materials and rated them according to the porosity and surface roughness and their material resistance to biofilm. There's a couple other materials out there such as PE and PVDF, but those aren't really applicable in the market you're in, which is that healthcare. So according to what I've discovered, stainless steel actually has an excellent rating when it comes to the corrosion level and the biofilm accumulation. So it is definitely a preferred material. So we also started looking at the microorganisms in the welds and seams, and in this case, the porosity. So quartz, the one that I'm pointing to way down there at the bottom, that's a cleaning agent. But what's interesting is that water has less penetration than milk, which has less penetration than beer, which means beer should technically be a pretty good antiseptic and keep us well. I'm going to have to declare nonsense on that, because if that were the case, I would probably be the healthiest man alive. But unfortunately, that's not the case in here. So what we're looking at is that the soil microorganisms actually have a deeper penetration rate than the cleaning agents themselves. So it's really important that your material not be porous and that your weld seams and everything else that you're dealing with be smooth. So again, we're talking about that disease transmission. So how does it transmit from one location to the other? Well, here in the U.S., we already looked at the P-traps. That's kind of our preferred method for forming those seals, so you don't get the hydrogen sulfide gas intruding into your occupied spaces. So we use P-traps. Well, P-traps in and of themselves, they're dirty. I mean, they're what I consider the Achilles heel of any sanitary waste system. They're just dirty by nature. And what happens is that's really where everything starts to propagate, particularly when you have nurses that may be dumping food products down there, maybe beverages, even bodily waste. There was a percentage that excuse me, wrong screen. I want to try to find that because I found that to be really interesting. Was the percentage of hand sinks that are actually used for, well, I don't have that number, but there was a study that was done in the UK about the percentage of hand sinks in patient rooms that were actually used for hand washing, and the percentage was extraordinarily low. So I found that to be interesting. So they're getting used for all kinds of things other than what they're intended to do. But what happens is you get these pathogens that start growing in the P-trap, and there are studies that are showing that those pathogens actually grow throughout the piping system and spread at a rate of about 5 centimeters a day. So it can start at one sink and then run all the way down the line and start infecting other areas. And then you get a sink, and I know that the latest requirements are for the faucet itself to be offset so you don't get splashing directly out of there. But again, we were talking about a living, breathing system. Even if you get a high wind on the outside of your building over a plumbing vent, you can get some bubbling in the waste system in the trap. So again, on the microscopic level, you could be releasing those pathogens into your room via aerosol transmission. So here's some examples of pipe corrosion. So I've seen this many, many times. Even as an engineer, did some forensic work, some pretty heavy forensic engineering, probably about 15 years ago, with the gentleman I was working with in Los Angeles. And this is very common. I saw this over at my buddies at Dodger Stadium on opening day. They had the field flood last year. I don't know who follows baseball and recalls that, but that was a result of corroded piping. And, we see this all the time. And what you're looking at, if you're looking at the picture all the way to the left, that's in a vertical configuration. That's, straight up and down. Well, what happens is you get this hydrogen sulfide gas that forms in the plumbing system, and it finds a high point, and then it condenses. And when it condenses, it becomes sulfuric acid, and then it kind of drips down the piping system. So this is actually a waterway that you're looking at there, that squiggly line. And if you see the same thing in a horizontal configuration, what's happening is that it has to do with the specific gravity. And I have a really neat slide that kind of demonstrates that. So there's a few things that happen here. And again, we could be talking about kitchen, we could be talking about the sanitary area, just regular patient waste, any type of biological product that deposits in the bottom of a pipe breaks down. There's an anaerobic bacterial process that happens, and it breaks down all that solid material, and it off-gases hydrogen sulfide. Well, that hydrogen sulfide is in fact lighter than air, so it's going to raise to the top of the pipe, where it will condense, form sulfuric acid, and then rain back down on the inside of the pipe. This is horizontal, but you also saw in the previous slide that it can do it vertically, and it eats up the inside of your pipe from the inside. So that's what we're looking at here. So we know that hospitals are very, very complex buildings with many demands. You're looking for something that's going to be durable. You want corrosion resistance. You don't want things that are going to rot out of the walls on you, because once you get it in, it would be real nice to not have to deal with it again. Hygienic, subject to high usage temperatures. Maybe you have some RODI water, so we want to be sure that we're not ripping the piping apart. We already talked about the porosity, so we don't want that pathogen propagation. Easy to install, so if you're doing a retrofit, you can get in and out. Okay, according to Mr. Labonte, we're getting a lot of echo and repeat, so I don't know if people have their phones or computers on and their audio on. If you can, please be sure that that is shut down, so that way we don't have that issue. And I'll continue on. So sustainability. Actually eligible for LEED points, so if you're looking to get that, I can help you with that process as well. And as far as ROI, you're looking at about an 80-year product, so it's probably going to last longer than your building. So we talked a little bit about that fire safety in the plenum areas initially. Okay, so good. We did talk about that initially. So we know that the evacuation of the hospital takes longer than evacuation of a typical building. So it's very important that anything we're putting in these plenum spaces and anything we're doing is for maximum safety. Stainless steel is not a combustible product. It's very important to just know that right off the bat. And as such, it's not subject to the ASTM E84 or the UL 723 test, which is the Steiner tunnel, where they put the piping in there and they burn it at both ends. So you don't have to really be concerned with that 25. Okay, you don't have to be careful with the 25-50 smoke and flame spread. Not an issue here for you. Okay, fire safety. So one of the other areas you looked at is in your elevators. So you've got to make sure that the water from the firefighting equipment doesn't enter the elevator shaft. And the International Building Code does require a method to prevent that sprinkler water from entering the hoistway, as well as California Building Code. So there's several different codes that are out there in regards to that particular issue. So pipe and pipe areas, let's talk about that a little bit. In the event that for some reason you have no choice but to go ahead and install that piping over an operating room or an electrical room, and sometimes you just get stuck. I mean, as an engineer, sometimes you just get stuck, and it's unfortunate, but it does happen. But what we know is that you have to be very careful to protect those areas. The methodology for doing so, the NIH guideline that pretty much everybody goes by is it frowns upon the use of drip pans. So what you could do in that case is you could go with any type of dual containment system, pipe and pipe, with a leak detection system on the outer pipe. That way, if there is any type of moisture intrusion, you can make sure that that's not going to drip down into those sensitive areas. All right. Some more information on the piping and pipe. Pretty easy to do. There's only a couple fittings that are hard to manufacture. One of them would be that sanitary tee, because you can't really manufacture it, you can't do that out in the field. So they actually have to manufacture that and then weld the fitting with the pipe inside the other pipe. There's only a couple of them are like that because of the patterns of the fittings. Okay, so here's an interesting one. We're talking about the drainage to match the flooring. So that connection between the flooring and the floor drain is really important to ensure a hygienic solution. I'm kind of going to segue here a little bit because I'm in several markets. I'm in the brewery, food and beverage. We did the Orleans Parish Prison project with this. And what happens is people don't really consider that integration between the flooring material and the trench or drain itself, or the floor drain. And what happens is it becomes a leak point. To the point where the NIH actually has a guideline in here in their design policy and guidelines to tell you that the AE should be careful. You need to specify floor drains and sinks with the outlet connection that are compatible with the selected piping materials. It sounds like it would be a no-brainer. A good example would be let's go back to the Orleans Parish Prison, where they put in these floor sinks, and the piping system is not compatible with the floor sink they use. So what they did is they kind of stuck the pipe inside the outlet of the floor sink and attempted to put caulking in there, and it's leaking like a sieve. And of course, it's the piping's fault, even though it's a inadequate connection between the two. But you really have to pay attention to that, even with the way that the flooring system integrates with the top of the drain system. And I actually have a slide on that we're going to get into here. So we do have drainage to match the specific applications within healthcare. Kitchen facilities, so we have, and they do manufacture, those trough systems, gratings that are pretty easy to remove because of their weight, safe gratings, non-slip, hygienic design of the drainage. Those food service areas are very, very sensitive to that, and particularly what we were talking about, that corrosion earlier. Grease waste can be very detrimental to your plumbing systems. You've got to make sure that whatever you have in there is not going to be subject to the breakdown of the organic material. And if it's a long run, what's the thermal conductivity when you're talking about heat trace? So we'll talk a little bit. So this is Hygienic Pro. This is really our flagship drain, but this is the one that you would use in any area where you're looking for that hygienic application. We do a lot of this in pharmaceutical, again, food and beverage, brewery. So what we're looking at is a drain that really is very efficient for cleaning. It has to do with the channel design, neat and safe, durable, bonds to the floor very well. We have these little tabs that you pull down, and then when you pour the concrete, it becomes more integral with the flooring system, doesn't shift. The grates are cast stainless steel, not welded, so you don't end up with those little hiding points for the pathogens. High-capacity baskets, epoxy infill, and the shoulder, and again, the high-speed channel design of rounded edges. A lot of advantages to doing that. ORs, gas-tight drain solutions for sterile rooms, so you don't have that problem with that hydrogen sulfide gas or any type of pathogen transferring through the drain. It does perform an effective barrier between the sewer and the hygienic area, so no bacteria is going to end up in the room, and you can control the water outlet from the room, so you're not going to end up with any biological waste going down that drain until such a point as that's cleaned up. Then you can use a vacuum handle or a nipple pull to remove the top of the drain and then do your wash down accordingly. Same thing, patient room and bathroom. If you look to the upper left on that, we have threshold drains that, for the transition showers, fully ADA compliant, stainless steel as far as the spot drains themselves for just regular flooring areas, anti-slip gratings, and fully hygienic, and again, not subject to the breakdown and not subject to corrosion like, cast iron enamel drains. Laboratory. Again, we're talking the gas-tight drains, so we're preventing the ingress from the sewer. Same as we had in the ORs, you can use a vacuum handle or nipple pull. You can allow that controlled outlet from the room, and it is approved for all flooring types. So we do have them for the sheet vinyl flooring. We do have them for the coated floors. So it really depends on the configuration that you're doing with the flooring. We'll work with your flooring guys, and most of your stainless steel manufacturers will work with the flooring people to assure that you're getting the right solution for the right area. That's a bummer. This was a nice slide, too. I figured out how to do scrolling text in this. So for laboratory piping, stainless steel, anything you get within the U.S., by the way, from us in particular, is going to be 3/16. The code limits you to either 304 above grade and 3/16 below grade, but we found that really because the pricing is identical, there's no reason not to bring in the higher quality stainless for you. So anything that comes from Blucher is going to be a 3/16 L. And unfortunately, my text isn't scrolling in the left, but it was really neat because I had this incredibly long list of chemicals that we are compatible with. What I will do, or what any of the stainless people will do, is work with you right from the onset to make sure that we have your SDA sheet, and any chemical that you're putting down there is going to be compatible with the piping system. A good example of that, I worked with a fuel and oil company out of southeast Louisiana, and they gave me their chemical list, and one of the things on that chemical list detonates when it comes into contact with water. It forms a flammable gas. And they wanted me to guarantee the piping system was going to hold, and I could not guarantee the structural integrity of the earth, let alone the piping system in that type of configuration. And the point is, we'll let you know, and if we're not a good fit for you, I don't have a problem with that. We're going to point you in the right direction and help you get your building designed accordingly. Talk about the storage and cleaning rooms. So we have larger capacities, so we have buffer capacities. Let's say you have a tank room and things could end up spilling. You want to try to contain that as much as possible and do controlled outlet. We can do that. Side inlet from wash basins, we can do those. I don't generally see too many side inlet drains, or not side inlet, but side outlet drains in the U.S., but it is a configuration that's available to you. So drainage is special areas. So we're talking about the vacuum drainage systems. One of the major uses for Blucher is in the maritime market, marine market. So obviously cruise ships, naval vessels, they all use vacuum drainage systems because you can't just rely on gravity to get things where it needs to go. So again, special hospital areas, vacuum drainage, we have that available for you. Vacuum toilets, any type of configuration like that we can work with. And we also deal with radioactive evac. So if there's something that you have that's a specialty application, by all means, get a hold of us. We can put you in touch with the engineers and make sure that the solution we're going to offer you is acceptable. We'll work with your code officials to make sure that we can get approvals on that. And if not, we'll point you in the right direction. So one of the other areas of concern is roof drainage. And I know I'm being very, very Southeast Louisiana-centric today, but I have to do it. So we were working, there was a hospital down there that had a major roof collapse due to the incomplete installation of the roof drains. They hadn't got the overflows put in yet. So what happened is the water pools in the roof kind of collapsed. And then it actually blew out some fixtures at some lower levels too, and where it blew out was at the couplings, which is kind of the point that I want to make, is that we do have some solutions for that offers some additional reinforcing that you may not have with the typical drainage system. So let's talk a little bit about standard gravity roof drainage. Obviously, we're talking about that connection, that interface between the drain outlet and the drain pipe itself. We're not subject to the corrosion. If you have an area that's high pollution like I do in beautiful, hazy Southern California, occasionally we do get a little bit of buildup in the sky, and that rains down, and it's basically corrosive. So stainless steel is resistant to that. And again, it's resistant to the breakdown of organic material. So if you end up with leaves or other biological agents in the pipe, your drain itself and the piping system is not going to be subject to the same decomposition as some of the other piping systems out there. So it is a very viable solution for you, and cost-effective as well. Very light material, so it doesn't require as many anchors and supports. Green roof options, we have that as well for you. Blue roof, don't see too much of that here, but we do offer it. Siphonic, here's a good one. You mostly see this on large retail, but it is the preferred methodology for draining roofs over in Europe. You can use smaller diameter pipes, fewer roof drains. You don't have to do as much shoring or trenching, shoring, excavation, and backfill, because you can actually take this pipe from the center of the building all the way to an exterior wall instead of having to drop interior to the building and then having to do all the successive trenching. So it's a very viable option for you in this industry. Talk a little bit about the advantages, or push fit versus a welded pipe. So if you look at the bottom left, there's this beautiful rainbow hue welded joint. looks gorgeous, right? It's absolutely the worst thing you want to see, because if it's got that rainbow sheen to it and it's shiny, that means it's not passivated. So you take this wonderful stainless steel material, you put a torch on it, and you remove the passivation from it, and that becomes your corrosion point. So our answer to that is a push-fit system. Now, I've worked with this personally. You know, I was also a field plumber for a period of time, and I still occasionally have the opportunity to get my hands dirty. And I've worked with this pipe all the way up to 10 inch in diameter, and it is a very, very effective and very fast system to put together. No specialized workers. You lubricate the end of the pipe. It's got a O-ring inside. You slide that thing in there, let it dry, and it locks into place. Everything that you're going to get is going to be pickled before it even gets to the job site, so you don't have to worry about filling it with inert gas, welding, no specialized tools. You don't have to have a fire wash. I'm doing this OSHA 30-hour training, and if you look at the welding section, there's so much precaution that you have to take if you're doing field welding, particularly within a structure, particularly within a hospital. It's just mind-boggling. So acid pickling and passivation, we have our little spaceman there on the right, lower right. It's basically you submerge it in hydrofluoric and a nitric acid solution. So any surface contamination or dirt is removed with the residual of welding slag, scale, and then that protective film is not impeded anymore, and you can go ahead and get that self-healing property, and the oxide film will go ahead and reform and protect it. So it's the chromium oxide that really protects that piping system. Talked a little bit about acoustics, so you can see sound through walls to adjoining rooms. We talked about cast iron. So cast iron is about 22 dBA at 4, and stainless steel is about 22. So, you know, it's not a horrible sound quality. You're certainly not going to end up with a problem like you did in tract homes. I used to live in a tract home in the Carolinas, and I had my couch downstairs, and I'd be watching TV, and somebody upstairs would use the bathroom, and you'd hear that whooshing down the wall. Well, you're not really going to end up with that problem. So that's why I talked about the acoustics for you, because that patient comfort is very, very important. So the primary objection to stainless steel is really the cost. So if you were to look at the material cost, you would see that the material cost is roughly 300% more than the equivalent fitting in cast iron. But this is where it actually becomes interesting, is when you're talking about the handling, the amount of labor that's involved with the installation, hangers and supports, all of those things that are associated. So the total install cost, that's when you can really start to flip these jobs around. But if anybody were to ask me off the bat, let's say, I don't know, any of you were to call me, hey, how much more is this going to cost me than a traditional cast iron system? I'd probably tell you about 20%. But in some cases, it can actually be less. Now, again, this is New Orleans. This is the job we were talking about earlier. You can see that the material and labor on that project for stainless turned out to be about $340,000 versus what it would have been a $223,750 at cast iron. But that's a market with a particularly low labor rate, and that was $50 an hour. Now you take that same job to a location with a higher labor rate, and you can see that there was only a 3% difference. So if that labor rate only comes up to $100 an hour, which is actually more now for most major cities, it kind of really helps to bridge that gulf. Here's an example of that. So I don't expect you to read all the slides, and this is very high level. But what I wanted to show you is that the estimated number of hangers went from 734 on a stainless steel system to 1322, which is a 44% reduction in the number of the hangers. So even though the material costs were 300 versus 132, by the time you've reduced all that labor, you look at the total installation hours, it's the third green thing up from the bottom. You can see 800 total installation hours versus 2,900, which is a 72% reduction in labor on the above ground piping system. I tell people it's about a 50% reduction below ground and about a 70% above ground, and that seems to be holding fairly true throughout the market. But the same job with different materials, again, we're talking a 9% difference. But again, it's a product that is, it's like comparing apples to oranges. You've got this 3/16 L stainless steel system that is not going to decompose, is not going to rot, and we're looking at about an 80-year product versus, you know, even Duriron down at the John Wayne Airport in Orange County here in California. They were burning through Duriron in as quick as 2 years because of just the aggressive nature of the hydrogen sulfide, and even MIC corrosion was just eating up their piping system. So again, if I told you you could get 80 years on a product for 9%, that's a pretty good ROI. So really, it depends on what you want to do and what your budget can hold. So a wise man once said that stainless steel piping systems are used when the building owner and operator has a vested interest in a hygienic, low-maintenance, long-lasting system with an excellent return on investment. I am that wise man, Scott Steinler. Again, if you're looking for something that's going to last you the lifetime of your building, start looking at your stainless options. If you're looking for something to help you reduce the risk of the healthcare-associated infection, start looking at these hygienic solutions. By the time you've gone through one or two lawsuits, we can really help to save you a lot of money in the long run, not only operationally, but from a legal standpoint and a liability standpoint and a maintenance standpoint. It's just kind of a win-win scenario for everybody. So with that, it looks like I finished about 4 minutes ahead of schedule, and I would like to thank everybody again for joining me today. My contact information, I believe, will be provided to you. So if there's any way I could be of service to you, please do not hesitate to reach out to me. And with that, I will go to any questions that we may have.
For those of you attending on the phone, you may ask your question by dialing the star key, followed by the 1 key on your touch-tone phone now. Questions will be taken in the order in which they're received. If at any time you'd like to remove yourself from the questioning queue, simply dial star 2. Again, for those of you on the phone, you may dial star 1 now. You may also ask your questions using the chat pod located to the right-hand side of the platform.
I refuse to believe that I did that good of a job that nobody has any questions. That will be a first time for me. Okay, well, I'm not seeing much in the way of questions here.
We have a few typing in, sir. No one on the phone side yet.
Oh, nice. Okay, perfect. This is also the longest my kids have ever remained quiet, so I think we've set many, many records. Thank you, Oliver. I appreciate that. How many hospitals have installed? From a quantity standpoint, it's kind of hard to say, but here's a list for you. Perfect segue, thanks. Here's a slide for you, just kind of some of the references we have, and there's many, many more. But these are just the ones within the U.S. That we know about, or some of the ones within the U.S. And there's other ones all over the world that have used it. So I hope this list is helpful to you, and I can make any of the lists available to you. And the slide is available upon request. We just decided that we didn't want to put it out there because there's a lot of research that went into it that I'd rather not hand off. So if you do want the information, please reach out to me and I'll get you a copy of the presentation. So as far as I can't quantify exactly, again, how many hospitals, but I know that it's a significant amount. Yeah, it looks like we have another question maybe being typed in. So just as a reminder, if anybody is interested in maybe bringing this back to their facility or having some of their licensed engineers take the course, I can remove all the branding and all the proprietary info from it and get a little bit more into the research itself. I am intending to follow up with Arizona, both universities in Arizona, to see what the actual results are to that testing and to that sampling. I think it's going to be really interesting. And again, thank you, everybody. Is this in the VA master spec? I know we've done some VA work, but I do not know if it is actually in the VA master spec. I could reach out to my people with it, ARCOM, and see exactly how does, well, let me finish one thing at a time. I will find out if we are in the VA or what hospitals we've been used with that are VA hospitals or government facilities and get back to you. So, Brandon, these questions will all be available to me after so I can follow up.
Yes, sir. I can email those questions to you.
All right, perfect, excellent. So how does stainless steel handle repeated snaking and jetting? Very, very well, as long as you provide the adequate access fittings. So it's one of those things I feel I need to address. So some people have a tendency to go out try to promote their piping system based on the fact, or even, people that are maintaining their piping systems, what they're doing is they're shoving snakes down the P-trap. Well, that's really not the thing to do. I mean, there's wall cleanouts, there's floor cleanouts. You have to make sure that you have adequate access to the piping system. And as long as those fittings, such as your wall access cleanouts and your floor cleanouts, and even the fittings have the correct sweep to them, and you get that snake going in the right direction and not against the flow, and that way it's not really going to be tearing up your system. But again, access is key, because if you have that correct access, you have the correct sweeps, it prevents the snake from bouncing around on the interior of a piping system when you're running kind of against it and you're hitting edges. If you've never seen that, I have some really interesting videos on what happens when you kind of run the snake backwards and it finds a ledge and it starts dancing, and that'll absolutely rip the inside of your piping system apart. But in terms of how does it handle repeated snaking and jetting, perfectly. There's some great YouTube videos that we have on showing the hydro jetting of the piping systems. If you have areas where you're concerned about separation, and if it were me, anywhere like where you've got these 90-degree changes of direction, or if you're under a concrete slab and you want to make sure that piping is not going to separate, there are some reinforcing couplings that can be used in combination with these push-fit systems. Again, bearing in mind that even on a conventional system, you're only kind of relying on these mechanical couplings, and these gravity systems are only tested to about 5 psi. So the couplings aren't rated for a whole heck of a lot more than that. So, again, you throw these additional couplings on there, very inexpensive, overall compared to the project cost. It really does help provide that additional peace of mind for you. So, Ali, I'm going to get these questions and send you some follow-up information, show you some nice videos on that, and I'll show you the snake dance video. That's one that's really good to watch too. So there was a question, where would we contact for a copy of the slides? I guess it will come my way, and I'll make sure that if I have all your contact information, I'll get you everything you need, and stuff you don't need for that matter. And you're welcome, sir.
Just a quick reminder for those of you on the phone that it's *1 to ask a question.
Now, that must be it. Okay. Well, I thank everybody again very much for staying awake and joining me today. It's been a lot of fun. It was a lot of fun working on this, a lot of fun researching the topics, and I had a good time presenting it to you, and I hope you found it informative. And with that, I bid everybody a very good day, and thank you for asking me to join you.
Thank you, ladies and gentlemen. This concludes today's event. You may now disconnect your lines.